Okay, now you see integration by parts. We have learned this. The formula is u integrate u dv is equal to uv minus integrate v du. So when do you use integration by parts? Where we have algebraic, this is x is algebraic exponential, and remember I told you already the u is always the algebraic. Okay, you cannot change, because if you change you cannot get the answer. Algebraic, trigonometry, so the u is always the algebraic. Okay, then after that we have exponential, trigonometry. This one is free. If you choose this one to be the u, then this one to be the dv. If you choose the trigonometry to be the u, then your dv will be this one. So this one is up to you to choose which one you want to choose. And then the exponential and trigonometry actually usually involve two times. You have to use the integration by parts formula twice. And then after that we have this one, algebraic and logarithmics. So the u is always the logarithmics. Okay, and then today this one we have learned all this. I've already shown you the formula. I've already asked you to try. And then today I'm going to do this one, the last one in this topic. That is algebraic and inverse trigonometric functions. Okay, that day I remember I give you, I can't remember which video, but I remember I give you, I said the x is here. Actually is no, the u is the arc sign. Okay, that day I remember I put the x here, is no. So you just do the correction. So for algebraic and inverse trigonometry, the u is always the inverse trigonometry. Then the dv is this one. Okay, so this is the correct one. Okay, so when you want to do integration by parts, you remember how you substitute your u. Okay, so now I give you an example. Okay, let's say we are going to integrate this x squared arc cos x dx. Algebraic, inverse trigonometry. Okay, so what I have to do here, I told you already, where is the u? The u is the inverse trigonometry. Why? Because this one we can differentiate. When I differentiate du dx, I will get negative 1 over square root 1 minus x squared. And then dv is this one. The rest we call it dv. Then we integrate is x3 over 3. Therefore, you get this. Okay? Then we substitute. So I told you already, always you write down the fourth bracket uv v du. So you write down the fourth bracket first, then only you substitute. Okay, then only you bring in, okay, u, that is your arc cos x, and then the what we call the v is this one, then v, then this one. Okay. Then after that you simplify. 1/3 you take it out, factorize, then you have this. Okay, this part you have to integrate. Okay, but this part, okay, you just substitute afterward, but this part you want to integrate. So this part, how to integrate this? Of course, when you want to integrate this is, you look at it, you know this is improper fraction. But this improper fraction you cannot change into proper by using the long division, because how are we going to differentiate how are we going to divide like this? You cannot. So you cannot, even though it's improper. So you cannot use partial fraction, because partial fraction you cannot use this, isn't it? Partial fraction usually the denominator can be integrated, can be factorized, and then you cannot use this method also. You see, for this part, let's say now I'm going to integrate this 1 minus x squared negative half. So you want to integrate the negative half. The negative half will give us half divided by half. This is correct. But the problem is, when I differentiate this, I will get negative 2x. That means what I have to do, I will get negative 2x. That means this one, the x squared, I have to take out. Then I can have a x here, then negative 2, isn't it? So this is already wrong. Okay, x cannot be taken out, so it's wrong. Therefore, what must you use? Actually, we use substitution. So here you have to substitute sine theta. Why I substitute sine theta? It's just like last time we did one. This time we have to substitute by sine theta, isn't it? You remember when I integrate this one, 1 over square root 1 minus x squared, I say we have arc sine x plus c. There I say you substitute x equal to sine theta like that. Last time we do this, so same. This is more or less the same. So what to substitute? You substitute sine theta. So when you substitute sine theta, your dx will be difference in sine theta is cos theta d theta. Then you substitute. Okay, this part already integrated, so you just substitute afterwards. So here I substitute. Since I put x to be, when I put x to be 0, I get the theta also 0. When I put x equal to 1, when I put x equal to 1, then the theta will be pi upon 2. Then this one is sine cube theta, 1 minus sine square theta square root dx is cos theta d theta. And then this is cos theta can cancel. Therefore, you get here is sine cube theta. So how to integrate sine cube theta? Just now I say we have two methods. One is using the identity. That's why I show you already. Or I use like that. I break them. Then the sine theta, sine square theta, I can change to 1 minus cos square theta. Then after that, okay, this part I substitute the limit, I get 0. Then here I get 1 over 3, then 0 to pi upon 2. I multiply inside, I get sine theta, cos square theta. And this one can be written like this. Okay, this one 0, no need to look at it, consider anymore. So 1 over 3 sine theta d theta. And then this one is 1/3. Then here I'm going to integrate the 2. But here I'm going to integrate the sine. Okay? So when I integrate the sine, I get negative cos theta. Then I differentiate this theta, I get 1. That's why I don't have to add anything. Just integrate sine, I get negative cos. Then minus, here the 2 will give me 3 upon 3, isn't it? Power 3 upon 3. And then I differentiate cos, I get negative sine. Negative, so negative 1. That's why it becomes positive. Okay, positive 1 over 3. Then this one becomes cos cube theta over 3. Then I just substitute. When I substitute, this one cos pi upon 2 is 0. Then when I substitute cos 0, I get 1. Then here also I substitute. Okay, 1 over 9 taken out. Cos pi upon 2 is 0. And then cos 0 is 1. That's why I get this. And finally I get this answer. So this is the answer. Okay, so we have finished all the chapter. So you can try all the questions. So if you have any problem, you just send to me. I will help you. Okay, we have finished all.